Minimum effort, maximum marks. Today, we are making the absolute smallest possible change to your exam technique for the biggest possible mark impact in your Cambridge IGCSE Physics 625 exam. No fluff, just pure mark scheme strategy.
0. That is the exact number of marks awarded to students who look at a pressure question, take the raw mass of a bus, divide it by the area of its tires, and just write down the answer. 0 marks. It's harsh, but this is the brutal reality of grade boundary risks in Cambridge physics. One misconversion, one overlooked detail, and your entire calculation is literally wiped out in an instant.
Okay, so let's look at why this happens. On the left here, we see exactly why ordinary, robotic plug-and-chug revision completely fails against Cambridge's multi-step pressure traps. You see a mass of 1.4 times 10 to the 4. You see an area of 1490, you divide them, and you lose everything. But look at the right side. This is the top band framework. You don't just blindly plug numbers in. You absolutely must convert mass to weight first. And you have to convert the area into standard SI units, which means meters squared. It's a perfect illustration of the gap between a standard, hurried guess and a guaranteed top mark.
Let's play data detective for a second with this London bus problem. We've got a mass of 1.4 times 10 to the power of 4 kilograms. We've got a tire contact area of 1490 centimeters squared, and the question asks us to estimate the pressure. If you just grab those raw numbers and rush to the finish line, man, you are walking right into the examiner's trap.
So how do we actually break this down and get our first quick win? First things first, the pressure equation requires force, not mass. So we've got to calculate weight by multiplying that mass by g, which is 9.8 meters per second squared. Second, there's that sneaky unit check. Centimeters squared has to be converted to meters squared by dividing by 10,000. And finally, we need to output the final answer in pascals to exactly 2 significant figures. Getting these specific variable conversions right is exactly how you rescue all those lost marks.
Now, in just a moment, I'm going to show you the hidden examiner clue in these types of questions that changes the answer completely. Seriously, it's a game changer. But before we get to that, you need the overarching framework that makes spotting that clue blindingly obvious. Because if you miss this next framework, you're just going to keep falling for the exact same calculation traps over and over.
Which brings us to our foolproof 4-step top-end framework. This is how you transform a vague, unitless guess into a definitive, mark scheme-aligned answer every single time. Step 1. Concept. What are we actually doing? Is it pressure? Speed? Step 2. Evidence and data. What raw numbers are they giving us? Step 3. Scientific reasoning. This is the big one, where your unit conversions and formula structures actually happen. And Step 4. Examiner wording, meaning getting your significant figures and final units absolutely perfect for the mark scheme.
All right, let's escalate the stakes a bit and apply this exact framework to a much harder, interactive challenge. Look at this route taken by an airplane flying from New York to Singapore. This right here? This is where Cambridge separates the average students from the absolute elite. The problem is asking us to estimate how far it is in kilometers without using a calculator, using the simple equation speed equals distance divided by time.
So, extracting the raw data, we get a speed of 840 kilometers per hour and a time of 17 hours and 22 minutes. Now I want you to pause for a second. Look really closely at this specific set of data. Can you spot the hidden calculation anomaly? What is the fatal trap the examiner just set for you? Boom, right there. This illustrates that fatal mistake perfectly. Over on the left, the flawed answer takes 17 hours and 22 minutes and lazily writes it as 17.22 and then multiplies it by the speed. Listen closely to this. Time does not work like a base 10 decimal. 22 minutes is not 0.22 hours. No way. On the right, we see the improved top band conversion method. You have to calculate the fraction of an hour. 22 minutes out of 60 is roughly a third of an hour. Just that one difference, that alone is what costs thousands of students their top grades. Okay, remember that examiner clue I promised you a few minutes ago? Here it is. Notice the strict definition of the word estimate. When Cambridge uses the command word estimate, especially when it's paired with without using a calculator, it dictates a completely different mental math approach to your scientific reasoning. 17 hours and 22 minutes. In an estimation, you round that to simplify the math. Maybe you treat it as 17 and a third, or honestly, just 17 hours, depending on the required precision. You simplify the 840 as well. The examiner is testing your grasp of real-world magnitudes here, not your ability to act like a robotic calculator.
Let's run a quick examiner-style correction session right now to just permanently wipe out these pitfalls. When we track the most frequent mistakes, 3 major culprits always show up: missing units entirely,
rounding numbers way too early in the middle of a multi-step calculation, and plugging in the wrong variables, like using mass when the formula strictly calls for weight. So your correction protocol is simple. Always state your units. Always carry your full, unrounded values through the whole calculation and only round at the very end. And meticulously match your formula variables.
Before we wrap this segment up, I really want you to lock this final answer checklist into your memory. This totally reinforces our minimum effort, maximum marks mindset. Every time you finish a calculation, ask yourself, are my units matched and clearly stated? Did I apply the requested significant figures, like the 2 SF required in that London bus problem? Did I avoid early rounding errors? And finally, is the final magnitude reasonable? I mean, if you calculate that a London bus exerts the pressure of a pinpoint, you've definitely made a mistake. Always, always do a reality check.
Now, mastering these calculations is a massive leap forward, but frankly, it is only half the battle. To ensure you never miss out on these crucial frameworks and continually elevate your exam performance, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Hit it now so you have these robust, exam-saving strategies permanently locked into your feed.
Because here is the real unresolved issue that leaves so many students completely stuck. Sure, you can perfectly calculate pressure or speed using the formulas now, but how do you secure full marks when the examiner links this exact calculation to a complex data analysis graph? That is exactly where the absolute hardest exam questions live. To master the mandatory data analysis skills you absolutely need to survive those final grade boundaries, jump right into our next explainer on that exact topic. It's the logical next step, and you don't want to miss it. I'll see you over there.